In exercise 2e, we're going to revisit integration, but this time our integration method will be the method required for finding the primitive function of an exponential. Now, knowing that the derivative of an exponential gives e to the x, it would make sense then that the integral of e to the x would take us back to e to the x and obviously plus a constant. So while the method of integration is changing because our function is a different family of functions, the other rules about integration still apply. So we don't integrate a product, unless of course, remember I said to you after I'd been to the HSC feedback that if you had the integral of a function time, and this is a product, of its derivative, if you recognise this situation, and yes, that is a product, then of course, yes, you can do that integration. But in general, we don't integrate a product. We don't integrate when our function is in the denominator of a fraction. We don't integrate if our function is under a square root. These are all things that we have to make an adjustment to. So we have to adjust our product if we see a product. And yes, there's a question here where you will see a product. And here, example 4, you can see a product and you're being asked to integrate it. However, we'll be able to remove that product. We'll be able to expand brackets and get it into a situation that we can integrate. And if it was our function was in the denominator of a fraction, we'd take it out and we would introduce a negative index, etc. So all of those rules about integration still apply. However, the functions that you're going to be asked to integrate now are going to involve e to the x. So remember also that when we differentiated e to a little function in x, then we had this constant outside e to the a of x plus b. So you could be asked to integrate that situation. Now, I don't call that I wouldn't even call that a product of functions. It is a product, but a is not a function in x. A is a constant. A is a constant. So if you find you're getting the integral of e to a little function, then you would have been hoping there was an a sitting in here as well. If there wasn't an a sitting there, then that means that a, or that constant, got cancelled out when it was differentiated. So now we've got to include that constant back in the denominator so that it cancels out. You'll see examples of that, and I'll talk more about those situations when we get to them. But for now, just one more thing before we start some examples. Don't use the process of add 1 to the function, add 1 to the index, divide by the new index, because that was how you integrated polynomial functions. Our emphasis here is on the exponential function. So, we won't be using that rule to integrate. Okay, let's have a look at the example. The integral of e to the 3x plus 2. So we're jumping straight into a situation like this. I can see that it is e to a little function in x. Now, ideally, I would have preferred the integral of 3 times e to the 3x plus 2. And you might be saying, oh, why? Why? Because remember, if I had e to the 3x plus 2 and differentiated it, then I'm going to get e to the 3x plus 2, but then I've got to multiply by the derivative of this little function, which is 3. I would ideally like to integrate that whole thing because it would simply take me back to e to the 3x plus 2. However, so the integral of 3e to the 3x plus 2 would be nicely e to the 3x plus 2 plus a constant. However, that's not what they gave me. There is no evidence of the 3 here. So what I know is that when this function was differentiated and they brought the 3 to the front, the 3 got cancelled out. Now, how would you cancel out that 3? The only way you can cancel out the 3 is if the original function had actually been 1/3 e to the 3x plus 2. Now, differentiating that, you can see it's 1/3 e to the 3x plus 2 multiplied by now the derivative of this, which is 3. Those 3's cancel out, and you get the derivative now of this function is what you had to have in order to to get e to the 3x plus 2 as your answer. So, integrating e to the 3x plus 2 will mean that, yes, it did come originally from e to the 3x plus 2, but there was more to it because there's no evidence of the 3 here. For that 3 to disappear, there had to be a 1/3, like this is suggesting, in the original function. And of course, it's an indefinite integral, so it's plus c. Now, I won't be surprised if you hear that for the first time and go, oh, that was all very confusing. If that is the case, pause the video now and rewind it and take it a bit more slowly. Go back and actually maybe you actually write and calculate these things for yourself rather than just watch me do it. So before you see me actually differentiate these, you try it on a piece of paper yourself until you are convinced that the integral of e to the function in x up here, when the derivative of that function doesn't appear, when that derivative doesn't appear, then you need to factor that in to the primitive, saying, well, that derivative somehow got cancelled. I have to factor that in to the primitive. Okay. And there's some of the more difficult ones, actually. Had I started with this one, you probably wouldn't be quite as confused. Example 2, the integral of 1 minus x plus e to the x. Okay, well, you know what? If that e to the x wasn't there, and you were just integrating 1 minus x, you would actually be using this rule. Add 1 to the index, divide by the new index. So the question here is made up of, we would say, a very simple polynomial and an exponential. So yeah, they might still combine some polynomials in with exponentials. And as long as you recognise they're just polynomials, then you will integrate as you would have in the previous chapter on integration. So let's see how we go there. The integral of 1, well, with respect to x, that goes back to x. The integral of minus x came from minus x squared on 2. See here how we did this? We did this sort of introducing what we needed back in the primitive function in order for things to cancel out. And then plus e to the x. E to the x comes from e to the x. And of course we've got plus c. I'm going to stop the video there and do another couple of examples in a new video. You might be able to, even at this stage, you might be able to do some of the very early questions in the you do. You might be able to do some of questions 1, 2, 3, just practicing what you've seen there in those 2 examples that I've done.